So yeah, I called this talk Flink in Containerland, and to some extent that's true. I'm definitely talking about getting Flink working in containers. I know have been some other talks about Flink on Docker and so forth. This one, the flavor here is going to be actually more particularly Flink on Kubernetes for a couple of reasons I'll get into. So yeah, what's this talk about? Basically, over the last much of this year, actually, I've spent thinking about these kind of problems. First, getting Flink on Docker, and then earlier this year, like around May, we got a public Flink image up. So you can Docker run Flink these days, and then I, wanted an excuse to play more with Kubernetes, and so I got Flink working on Kubernetes. And then fast forward a few months, and it was tying it all together for the DA Platform 2 and the application manager that you would have seen demoed yesterday. So this is a bit of a journey, running into a bunch of issues and learning some lessons from them. So why Flink in containers? One is that it kind of fits our ideal deployment model, and I'm going to talk about that a little more in a minute. There's a lot of cool advantages here, dynamic resource allocation, scaling, but I think most importantly, it's about the more application-oriented versus machine-oriented philosophy. Thinking about Flink applications, like we talked about with the DA platform, as opposed to running a big cluster and running a big Flink cluster. And then why Kubernetes? I like it a lot. I think it's really cool, but it has some actual cool, nice things to talk about. A principled API design, both in its data API and how you interact with it. This resource-oriented approach, kind of declarative syntax about how you configure things, and it cares a lot about filling this one particular layer of infrastructure and being really good at that and not reaching out in both directions to try to take over the world. But most importantly, it provides all the necessary parts to effectively run containerized applications such as Flink at scale. So a couple of parts here. Setting the stage, going to give a little more background of what it takes to deploy Flink, and a little bit of necessary background on Kubernetes. Then I'll get into the challenges and solutions that I've run into. Actually, solutions, some of them are a little more like open questions. And then have time, hopefully, for a bit of Q&A at the end. So first, a brief recap of Flink architecture. Most of you are probably overly aware of this already, but I'll go over it anyway. A Flink cluster has a job manager. It's central coordinator for the cluster for jobs, and it orchestrates task distribution, giving work out to the task managers, distributing the blobs of code that need to run. And it also serves the Flink UI and the HTTP API that goes along with it. And then additionally, there are task managers, runs your user code, talk to the job manager. Here's it in a nice little diagram in case it's unfamiliar. I expect you're all pretty good on this. And I also noted here that you can have like a backup hot spare job manager with Zookeeper for leader election. And then I just wanted to do a brief note. This has actually been talked about more than I expected, so I still have my slide in here. But we have this idea, and there's kind of a bit of a changing philosophy here about instead of running like a big Flink cluster, sending it many jobs, to actually tie the life cycle of the cluster with the job. And the goal of this is that the job itself should be like a first-class entity. We don't want you to have to think about Flink clusters. You care about your Flink application, and you deploy that onto something that is in charge of actually and good at resource management, like Kubernetes, Mesos, Yarn, that kind of thing. Just a little bit of background here is that like early versions of Flink, or what became Flink, were heavily inspired by the Hadoop model, and that's why you have nodes with different roles, the management processing nodes. And then if you want to get a little more into this change of philosophy, go look up Flip 6, and you can see some of this ongoing work to make Flink more of a native citizen to this kind of infrastructure. I think actually Xiaowei in his keynote this morning mentioned this work as well. Now a little bit about Kubernetes itself, because I'm pretty sure you all know about Flink, but maybe not Kubernetes. As I mentioned, it's resource-oriented. So you tell Kubernetes about what you want, and then it's responsible for actually getting there. One example is you say, of this container, I want you to keep 3 replicas, and also I want you to only schedule this on nodes with a certain label. Maybe that label corresponds to an availability zone in AWS or so forth. And you could accomplish this with a Kubernetes deployment. Another example is give me a load balancer listening on 443 and proxy back to containers with this particular label. And this corresponds to a service. And again, you push this one bit of configuration to Kubernetes, and it makes it happen depending on your environment and so forth. There's actually quite a lot of different resource types. I'm going to talk about a few core ones here. But it is actually very extensible, and the APIs are set up that it's good at things like extensibility, providing your own controllers, and also forwards and backwards compatibility built into the syntax and how you construct these resources. So some of the core types here. First, the pod. This is kind of the atomic unit on Kubernetes. It's one or more containers running on a node. The one or more is pretty useful because you can actually have multiple containers, but since they're guaranteed to be on the same node, you can do things like share a file system, talk to each other on localhost. You have a deployment. I mentioned this just a moment ago. It keeps a number of pods running, and it can do some other useful stuff, such as given a strategy of how to handle upgrades. A service is, perhaps unlike some other frameworks, pods and containers themselves, you don't communicate directly with them per se. You don't address a pod. A service is meant to give a name to one or more pods, in a sense. And it can do this depending on how you configure it. This can actually itself cause like an ELB in AWS to be created backed by pods, which is pretty neat. Or it can effectively just give a name to a pod that you want to keep track of, such as later we'll put a service in front of a single job manager. And then finally, a config map is useful in this case. It's basically just data that you can then render into pods as environment variables or files. And now, given that you know how Flink's deployed and you have this kind of basic terminology for Kubernetes, we can talk about what a Flink cluster would look like in Kubernetes. First of all, you have a deployment for the job manager. We still use a deployment and tell it to maintain one replica instead of just a pod, because a pod can actually come and go. There's nothing that if a pod dies, if the node it's running on dies, there's nothing there to bring it back. So we still use a deployment here, and we instruct it to give a label to our container, our pod, such as Flink job manager. Additionally, we'll add a service that just sits in front of this job manager so that the task managers can address it by a name. And the service is configured with that same label, and that's how it knows where to proxy to. The task managers also in a deployment. This time it's in because you probably want more than one task manager, but you can, if you wanted to scale up, for instance, it would be just a matter of updating that value and bring up more pods and configure them appropriately. And then, as I mentioned, there's this config map, which can produce, for instance, create an Etsy Flink directory, wherein there's a Flink conf core site configuration files. So I was originally going to make a diagram about all this, and I was like, how the heck do I do this? It's all very abstract stuff. None of this stuff actually exists. It's just configuration in Kubernetes. And so I was putting a quote from one of my favorite movies. But then I said, what the heck? And I tried to make a diagram anyway. So I'm not going to repeat all this stuff about the service deployment config map, but here's a nice diagram for you. The two deployments, the service on all the top, Kubernetes. So that's the end of the part 1 here, and now I'm going to jump into some of these challenges and solutions that I've run into. First up is this this thing, Job Manager RPC, and if anyone has actually gone through this exercise already, they probably know exactly what I'm talking about. But first, in fact, I would say networking is the source of most challenges with Flink on Kubernetes, and I think this will be true of pretty much any system that utilizes overlay networks in the same way. So Docker Swarm, I think, I haven't actually really tried it in the same depth, but there are just some things that are different in this kind of environments than when you have, say, a bunch of hardware on the same layer 2 network, all plugged into the same switch. You just get an IP address, and you can talk to them. And if you if you actually do the thing that I just described with the 2 deployments, the service, the config map, probably just not going to work, or rather, it's not going to just work as we'd like it to. And the most visible issue you will run into immediately is because Flink uses Akka to communicate not only between the task managers, actually sending data back and forth between the task manager and the job manager. It's also used for the Flink CLI, usually used to submit jobs to a cluster. But the catch here is that Akka actually requires that the name that you are trying to communicate with matches the name of the thing that the thing you're talking to is also configured with. It's a bit roundabout, but I'll have an example shortly. So if I'm connecting from outside Kubernetes, maybe I did kube control port forward to forward a port locally. Maybe it's over a load balancer. A lot of different options here. All your messages are actually just going to be silently dropped. Not so silently, it's debuggable. So as a quick example of this, I've got a job manager running the particular name. I have a service that listens on the Flink RPC blob server UI ports and sits in front of the job manager. And then I've configured both the job manager and task managers with the name of that service so that everyone can communicate to the job manager via the service. Now, task managers work fine because job manager thinks its name is my Flink cluster job manager, and so do the task managers. So everyone kind of agrees on the name here. But if I want to submit a job now, I port forward into it. So let's say I forward port 6123, which is the default Flink RPC port. It's going to look like it's totally working because the TCP connection is fine, but then it's just going to sit there and, until it times out. And if you go look at the job manager log, so I was lying when I said it's silent. It does show up in the log saying I ignored this message. Not super ideal. The most immediate solution, and I know for a fact that we have users who do this, is that they run a pod in the same Kubernetes cluster that happens to have their code, so that then they're like the task manager. They talk to the job manager over the same name. And I mean, yeah, the users have even hooked this up to like a CI system, so it builds their code, builds a Docker image based on Flink, pushes the Docker image, creates a pod in Kubernetes that runs that code, that runs the Flink CLI. It's a bit roundabout, not so totally ideal. The other solution, likely a better option going forward, is to use the HTTP API or the UI. I'll put the HTTP API in kind of quotes because that you can use it, though it kind of it grew out of the UI. So the UI needed some HTTP endpoints to get data, and they were added to Flink as needed. So it's not like there's a specified, intentionally designed API there. But you can use it for job uploads with a little work. It's not subject to this addressability problem. Some downsides, it can be kind of hard to secure. Some users want to turn off the UI altogether for security reasons, but then they realize they need to do these job submissions, and they don't want to do the other solution I provided. It's a bit of an area for improvement. Next point is just a brief one about port configuration. There's a couple of services in Flink, especially the blob server, but also Queryable state, that by default choose an arbitrary port. The first time you try all this and nothing works again, you'll find out your task managers are having trouble reaching the job manager because they're actually talking to a Kubernetes service on a totally random port that it's not listening on at all. So pinning these ports is something you have to do. I chose these because they're the next sequential ones after 2 ports Flink already uses for RPC and some other stuff. HA mode, I'm using scare quotes again because HA mode somehow is kind of a misnomer. For sure, you need to activate HA mode if you want to run like multiple job managers, like I mentioned you can do before, where they coordinate, do a leader election on Zookeeper to decide which one's the leader. But it's actually really important that you always use HA mode in production, because if you don't do that, then the job manager is storing some critical states, such as what checkpoints have been completed and so forth. It stores it locally. So if that pod goes away in Kubernetes, you would actually lose that data, and you'd actually lose your ability to then recover from a checkpoint. Whereas when you run it in HA mode, even if you only have one job manager, all this information is stored in Zookeeper, where it would be picked up when the job manager recovers. And I suggest in general, using one job manager in Kubernetes. That's kind of the advice we give right now, because for the most part, Kubernetes or Mesos or Yarn should handle replacing the job manager if it fails. And like in practice, I've tried this out a few times. The various timeouts associated with redoing a Zookeeper leader election and finally handing that over take roughly the same order of time as it would take Kubernetes to notice and replace your job manager. So it also keeps things a little simpler, less resource requirement. If you do want to run more than one job manager, there's a little gotcha here, which is that if you try to access the UI once again outside the Kubernetes environment, you'll find quickly that if you go to the non-leader, it's going to redirect you to the leader with its internal host names, something that's totally probably not routable or resolvable, rather from outside the cluster. One clever solution I saw on the mailing list was you actually have the non-leader fail in Kubernetes called a readiness probe, which should make it not receive traffic. It's a little, I don't know how I feel about it, but I think it would work. So a possible improvement here to Flink would be to proxy HTTP requests to the non-leader over to the leader instead of just trying to redirect them. Next thing is, how do I get extra dependencies and so forth into the container so that Flink can use them? For most of your dependencies, the easiest thing is probably building a fat jar. You put all your code dependencies in the jar during your build process, and then they're all there. But there are a few exceptions for the libraries that Flink itself needs, not just your user code. One example would be if you want S3 state storage, you need a few jars from AWS, like the Hadoop AWS jar, for example. That has to be there on the class path for Flink. Like logging, metrics, libraries, and so forth. The easiest thing to do is build your own downstream Flink image where you inline those jars. Though I've also successfully been able to use Kubernetes init containers feature, which allows when a pod comes up to run a single container first. That could load in some libraries on a file system path, and then it runs the Flink container, and you mount that into the lib directory as well. It's a bit roundabout, so I still think it's probably easiest to just build your own Flink image. So yeah, for Queryable state, such a cool feature that's I think going to be used more and more. It is a bit tricky to get working for very similar reasons as we've already talked about. It totally works out of the box, once again, if you're inside the same overlay network, the same Kubernetes environment, because then you can talk to the task managers over their own host over their own IP addresses. But these also suffer, for instance, from the Akka addressability issues. So if you slap a load balancer in front of all your task managers, they're going to ignore you for the most part. So some possible improvements here would be, one, like the non-leader job manager situation, if you enable the task managers to proxy queries over to the correct task manager, kind of like you could imagine Cassandra doing, then you can just do that. You put a service in front of them. You configure your client applications to connect to that service, send their requests. It's all good. Another solution here, though, you'd have to do this work yourself, of course, is you build a service yourself that does this proxying. This actually could have some nice advantages. You could scale this layer independently of your Flink job. You would have a chance to put in some caching of these results. I mean, you could change it from an Akka to an HTTP API, which might be better for the applications you're building. And also, it could give you a way to maintain some kind of partial availability from cached values when the underlying Flink job is going away. Or if you, say, upgrade a Flink job, like a kind of a red-blue kind of thing, you bring up the replacement and it's still running, this service could actually pull values from both or either so that you don't have any downtime at all. But it's an exercise for the reader. This is also a pretty popular topic with some folks I've talked to. How do we do the usual TLS stuff? How do we get security encryption features in Flink in an environment like Kubernetes? The reason it's tricky is that like pods, there are very few predictable host names, predictable IPs. As soon as you say change the Kubernetes namespace, the FQDN of your pods is totally different. How do you predict this stuff? I mean, if you're very liberal with wildcard certificates or something, you might be able to make something work. One solution I've thought of, haven't actually tried this, fair warning, is actually when you want to launch one of these clusters, you can generate a Java trust store, key store, that has, you generate a key pair and a single certificate, and you say that trust this and only this certificate for internode communication. So somehow we're reinventing symmetric encryption in the convenient wrapper of TLS. It seems like it should work. Someone should try it out and let me know, though. Another option here is if you use, so Kubernetes, I haven't really talked about what an overlay network really is, but it is a feature of Kubernetes that there can be different implementations about how the networking looks from a pod's perspective, how you're talking to services and other pods. But I know at least one of the commonly available pluggable overlay networks for Kubernetes support encryption in some fashion on the wire. Now this is, totally up to your requirements whether this suffices. I know that, depending on if you have regulatory concerns, maybe they actually require a higher TLS process to process. This is kind of letting the network do a bit of magic, but if it's, as long as your bytes are encrypted on the wire, that's what your requirement is, this could make things actually really nice and easy. Yeah, so I'll get to resource allocation too, because this is something I think people ask a lot of questions about, and I don't know if my answers will actually satisfy you here, but one is how many slots should each of these task managers have? So when you're running, if you're running Flink on bare metal and you have a 24-core machine, you put 24 slots on there and call it a day. In an environment like Kubernetes, not only do you have much more fine-grained control about how many resources each of your pods get. Like, you could even have a heterogeneous collection of nodes. Maybe you have some nodes that are bigger than others. It doesn't make sense to just like rely on what the underlying hardware has. So you do have to make a decision here. More slots in a task manager can save a bit of overhead. There's the threads, the memory that a task manager has that are shared between slots. On the other hand, if you keep the ratio lower, you have more task managers like with one slot each, for instance. You can like theoretically improve your time to recovery. because your cluster is more distributed out. But of course, if your cluster is spread across more machines, you actually have a higher chance of some failure within your cluster. CPU and RAM is another question. Ideally, like in the other cases, each slot would have about one CPU because Flink, if everything's fully utilized, in theory, each task slot would use exactly one CPU. Let's see. The RAM to slot ratio is very application dependent. I tend to use 1 GB minimum. It's mainly coming out of the, we are running a JVM here, and pushing that down can take you have to be a little bit clever with your tuning and so forth. So I tend to start with about a gig. From gig for the job manager, a gig for a task manager if my state requirement isn't high, and then as you need, grow from there. And I'll also mention, if you missed it, Robert Metzger had a talk yesterday about Flink operations, and I highly recommend it. It was really useful. Actually, I say end of day. I think it's available now if you missed it and want to check it out. So I'm actually running a little ahead of time here, but I think that's always good. So containerization, these resource management platforms, I think they have a bright future, and I think Flink is in the right place for it. There's plenty of room for additional work, but I think thinking of Flink applications, long-lived, using the dynamic scaling and everything that you get from a system like Kubernetes, I think it works really well together. And I'll say that from at least the points that I talked about today, my most wanted Flink improvement would be getting a grown-up HTTP API for management of things. I think that would make quite a lot of this stuff a lot nicer. Everything from job submission to monitoring to health checking things. It'll if the CLI gets rewritten to use such an API, you don't have any more of these ACA issues. If we specify the API, for instance, with Swagger, then people can build services to their heart's content to manage Flink jobs a lot more effectively. And I think that'd be really nice. And additionally, if you have like rich health check endpoints, perhaps not only for the health of a job and task managers, but for jobs themselves, then you can actually utilize the Kubernetes feature of watching pods for health, see if they need to be replaced directly via this interface. There are a couple reading points. Quite a number of these issues I've written down in this Flink ticket, and so if you want to read a little more, or even better, if you want to contribute or comment on it, check that out. There's also questions about this every week, this sort of stuff every week on the Flink user mailing list. And again, I'll mention Flip6 again. If you just Google Flip6, it works great. So I would do that. So that's all I have on the main part of the presentation. Thanks. And I definitely have time for Q&A because I probably rushed through the whole thing, but we have to get out of here soon anyway. So, anyone have any questions?
Is there any experience doing the same thing on AWS ECS?
I haven't. I've played with ECS before. I have not done a lot of this stuff on ECS, and so I can't really speak to how networking works the same or different there. On Google has native Kubernetes support through GKE. And I think they do a bunch of clever stuff with their SDN, the way that they do networking, such that other machines within the same project can actually address a specific pod by IP address. In other words, all your resources, pods or VMs, actually are all in the same IP space, and you can just talk to them. And then, of course, there's firewalls and stuff like that. But no, I haven't tried ECS.
Any? Oh, yeah.
Thanks. I was kind of happy to actually see you mentioning those Akka hostname issues, since we also run into those. Did you consider or investigate actually changing Akka to get rid of this? Because, I mean, a lot of projects might run into this when wanting to deploy in a Dockerized or Kubernetes environment.
I totally did think about that. I ended up stopping short. So on the Flink issue I mentioned, I actually bring that up as a possible solution. For one, Flink, I believe it's still the case that Flink still has a fork, actually runs a fork of Akka, Flaka, to solve some other issues. I'm actually not totally up to date on that. That might be a possibility. I know Akka itself has some support for like an additional host name, like a public name that you talk to it as, but I don't think that's sufficient in this case. I think that as soon as you say, like maybe that works if you expose it over a load balancer, but say now you want to port forward to it, it really should just, you should be able to talk to it and it shouldn't ignore you, is what I think. It's an interesting idea. I don't know enough about how Flink uses Akka to know whether that's an actual viable change.
Okay, thanks.
Yeah, the Akka community, as far as I know, calls that a feature. And I think I would be willing to say that Flink is probably not using Akka in the right way in this situation. That's actually why my preferred solution is getting like having an HTTP API, for instance, for this kind of stuff.
I guess my question is that with all these still lingering issues you're talking about, is anybody running big clusters of this in production now?
I don't know this. I don't know
Are
this.
they?
Oh, sorry.
I mean, we're thinking about moving from Yarn to Kubernetes in the coming months, but
I would say that
I'm feeling a little worried about given some of the things you're talking about.
Sure.
Is that
there absolutely are quite a number of users using Flink in production on Kubernetes. I can't say, and I don't have a lot of information about the size of these clusters. But I would actually make a point that I think pretty much every issue I mentioned is, I think, much more of a quality of life problem than, say, a fundamental problem of running Flink on Kubernetes.
So people are working stuff out.
Yeah, and I think that the fact that all of these are evident and people are talking about them that's the direction things are going, and Flink will catch up to that. I'd say the more people that are doing this, the better. I think we'll get there faster.
Okay, good.
We still have time. Any more questions?
Right.
No.
Thanks a lot for coming.
Yeah, thanks again to our speaker.